This is the third note of the third unit on quadratics. So specifically, this is going to be our first note where we talk about factoring, and we're going to start off with trying to factor trinomials, which will be in the form x squared plus bx plus c. So before we get into factoring, we're just going to do a quick review of the expanding properties that we looked at in the last two notes. So the first is that distributive property, which we kind of refer to as that rainbow method. And again, that is where you are just distributing the monomial out front to the binomial in the brackets, which again just means you're multiplying. So we got this product here by doing 2x times x gave us that 2x squared, and 2x times -5 gave us that -10x. Okay, we also talked about the product of two binomials, which is that acronym FOIL, right? So first, outside, inside, last. And again, that's just telling you what terms you should be multiplying together. So you have x times x gives us that x squared. X times 4 is positive 4x. Negative 3 times x is negative 3x. And negative 3 times 4 is negative 12. Remembering that we're not done there, we have to collect our like terms because we have two x values there. So 4 minus 3 simply gives us that 1x. We also talked about some special product cases in the last couple of notes. And I told you not to worry too much about it, but we're going to recall it anyways, just in case you find that a bit easier. So the first was a perfect square binomial. So that's when we have a binomial, which is in brackets, and it is squared. So remember, if we were to properly expand that, we would have to rewrite that whole bracket twice, and then use FOIL, and then collect our like terms. But we learned that there's that special formula, which you can see over here. It's under the recall in blue. So when we have any binomial squared, the product after you expand is always going to be a squared plus 2ab plus b squared. And we can see that with this example, right? X squared is x squared. That negative 10x comes from the product of 2 times x times -5. And lastly, that 25 comes from that -5 squared. Okay, so that was our one special case. The other special case was a difference of squares. So that's when we have two binomials that are the same other than the sign, right? So one of them you are adding and the other you are subtracting. You have to be adding and subtracting that same number. If you do that, you will always expand to a squared minus b squared, and that's just referring to the two terms, right? A is the first term, as you can see on the left under the recall, and b is the second. Remember, it's always going to be subtract, so we simply just squared x to get x squared and squared 7 to get 49, and like I said, it always has to be minus. So now let's get into the new stuff here. So factoring. Some of you might have seen factoring before, others may not have. So the numbers that are multiplied together to form a trinomial. Okay, so that's what factoring is. A factor is those numbers that we multiply together to actually form our trinomial. So for example, here we have 2 times 3 equals 6. So those factors there would be 2 and 3, right? We multiply 2. Well, I don't want you to think of that as a coordinate. 2 and 3. And the product, remember the product is just the answer you get after multiplying those together. So the product here would be 6. Okay, so obviously that makes sense, right, with just 2 and 3, but we can also have factors that are binomials. So those binomials would include variables. So for this next example, we have x plus 1 times x plus 2 equals x squared plus 3x plus 2. So the factors here are x plus 1, okay, and those factors are, again, those numbers that you're multiplying together. So x plus 1 and x plus 2. The product, after we multiply those together, is the x squared plus 3x plus 2. Okay, so when we're factoring trinomials, what we are actually doing is simply the opposite of expand and simplify. So it's the opposite process of expanding. Okay, so how do we actually factor? So when we are specifically factoring a trinomial that's in this form, x squared plus bx plus c, we need to find two numbers whose product is equal to c, so whatever our c value is, and whose sum is equal to b. Okay, so again, you need to know product comes from multiplying. Okay, and sum comes from adding. Okay, so what this is saying is you need two, remember integers is just numbers, so two numbers who multiply to equal c and who add to equal b. Okay, so we must pay close attention to the signs of the term. Okay, and by that I just mean negative or positive. Okay, that's what I mean by sign. Is it negative or is it positive? Okay, so let's do some examples here to help you kind of better understand that definition. So we have two examples. So we're factoring trinomials. Remember, this is going to be different depending on what we're actually factoring. So this first example, we have x squared plus 15x plus 36. So the first thing I'm going to do is I'm just going to label. It's always going to be a first. A is your x squared term, b is your x term, and c is your integer, your number that doesn't have a variable. Okay, so according to our definition here, we need to find two numbers whose product is equal to c. So in this case, c is 36. So you can see that's why my chart here is titled product of 36. Okay, so two numbers that multiply to give us 36. And we need those exact same numbers to add to equal b. So we need to have them add, in this case, to 15. Okay, so you're always going to draw a table like this, and you'll see me draw it a little differently, but you have this on your notes, so go with this first. So basically, this 1, 2, 3, 4, 6, these are just numbers that are there to start you off. Okay, so on a test, on an assignment, they won't necessarily be there. You would have to come up with those numbers. Okay, but you're always basically going to just start with 1 and continue on. Because this example, we have two, like our b is positive and our c is positive, we don't have to worry about trying to find negative numbers because we know that the two numbers that multiply to give us 36 and add to give us 15 have to be positive. Okay, so how we fill in this chart, so remember product, so we need to multiply to 36. So it's saying, okay, 1 times what gives you 36? Well, 1 times 36 gives me 36, right? And then the sum part is saying, okay, those multiply to give you 36, but do they also add to give you 15? So these, we would add them together and we would get 37. 37 is not 15, right? So we know right away that those are not the correct factors, right? Because they don't satisfy our definition up here. They don't satisfy those two conditions. So we move on. Now we're going to see 2 times what gives us 36. Okay, and another way to do this is 36 divided by 2 gives you what? Okay, because that is just the reverse. So 2 times 18 will give me 36. And if I add those together, 18 plus 2, I get 20. Again, 20 is not 15, so I know those are not my factors. Okay, those are not the two numbers that I have to multiply together to get my trinomial. Okay, so now I try 3. 36 divided by 3, or 3 times 12, will give me 36. If I add those together, I get 15. Okay, well, that's what I'm going for, right? So those are probably my factors, but I'm just going to fill out the other two just to be sure. Okay, so 4 times 9 also gives me 36, and if I add those together, I get 13. Okay, so it can't be that one, right, because we need it to be 15. And 6 times 6 will give me 36, and 6 plus 6 gives me 12. And 12, again, that's not what I'm looking for, right? So I know that my factors have to be 3 and 12, right? Because 3 times 12 multiplies to give me C, and it also adds to give me B. So after I have those factors, all I need to do, I'm going to make 2 brackets. Okay, they're both going to start with X and end with one of the variables. One of the values that we found in our chart, one of the factors, okay? So it doesn't matter which one is first and which one is second, okay? You just have to make sure that you put the correct sign. So because these are positive numbers, I'm going to have X plus 3 and X plus 12, okay? And now this here is in factored form, which means it's fully factored, okay? And keep in mind what I said about how this is just the opposite of expand and simplify. So what that means is if I were to expand and simplify this, so if I were to use FOIL here, I would end up with this trinomial. Okay, so they're just opposite things. So again, just like before, where we were going from vertex form to standard form, okay, we can write this in a third way. We can write this in something called factored form. So that means these two equations here are equal, right? If I can expand one of them and get to the other one, that means they're the same. Okay, so those are equal. All right, let's try another example here. So this one we have x squared plus 7x minus 18. So again, the first thing I'm going to do is I'm just going to label those A, B, and C. Okay, I know that I have to find two numbers that multiply to give me C, okay, which is negative 18, which you can see there, and add to give me B, which is 7. So because this value is negative, I'm going to also have to use negative numbers in my chart here, okay? Because I know that for two numbers to multiply to get to a negative number, one of them has to be negative, right? Or it's not going to get to that number. So we start with our chart here and we just fill it in. So again, negative 18 divided by 1 is negative 18. Okay, see how one of them always has to be negative. And then, of course, you'd add them together. So 1 minus 18 is negative 17. Negative 17 is not 7, right? It's not positive 7, so those can't be my two factors. Now I move on. Negative 18 divided by negative 1 is 18. Negative 1 plus 18 is 17. Again, that's not 7, so that can't be my factor. So I'm going to keep going. Negative 18 divided by 2. So you can think of it in two ways, right? Negative 18 divided by 2 equals what? Or 2 times what equals negative 18? Okay, so the answer here would be negative 9. 2 times negative 9 is negative 18. 2 minus 9 is negative 7. Okay, don't get too excited because we have that negative sign, right? So we know that it can't be that one either. So we have to keep going. Negative 2 times positive 9, though, will also give me negative 18. And if I add those together, I will get 7. Okay, so there's hope there, right? It could be those ones, but we're just going to finish out our chart. 3 times negative 6 will give me negative 18. And when I add those together, I will get negative 3. So it can't be that one. And last one here, -3 and +6 multiplies to give me -18 and adds to give me 3. So again, that's no good. I don't want 3. What I need is 7. So that means -2 and 9 must be my factors. Again, once we have the factors, we're pretty much set, right? When we write it out, it's really simple. It's just going to be x minus 2. Okay, so I have to include the negative there because it's a negative in here, right? And x plus 9. Okay, so now that trinomial is fully factored. All right, so that's the first half. Let me pull up the second half here so that we can look at our special cases. Okay, so we're going to be looking at the same two special cases as we did in that last note when we were talking about expanding and simplifying. Okay, so just like those were special cases for expand and simplify, they are also special cases for factoring. So if we're factoring a perfect square trinomial, okay, that means it has this form, right? A squared plus 2ab plus b squared. And we learned that in our last note. It's always going to be, your factored form is always going to be a plus b squared. Okay, in order for this to work, the first term has to be just an x squared. Okay, there can't be any numbers in front of it for our purposes here. Technically, you can have numbers in front, but we're not going to get into that yet. Okay, the last term has to be a perfect square. Okay, if you are like, what the heck is a perfect square? Okay, a perfect square is the product. So again, remember, product is the answer when we're multiplying. So it's the product of a number multiplied by itself. So for example, what does that mean? It just means 4 is the product of 2 times 2. 36 is the product of 6 times 6. Okay, it just means that these two numbers that you're multiplying together have to be the same. That's all a perfect square means. Okay, so if the first term is a simple x squared or 1x squared and the last term is a perfect square, then you might have a perfect square trinomial. Okay, so let's take a look at this example. So we have x squared minus 10x plus 25. So we are going to look at this in the exact same way, right? We have our chart. We know we need two numbers that multiply to give us c and add to give us b, which is -10. -10. Okay, so just like before, we are going to come up with numbers that will multiply to give us 25. Then we're going to add them together and see which one equals -10. Okay, so the first thing that comes to my mind is 1 times 25. Right, that will multiply to give me 25, but it adds to give me 26, which is not what I want, right? So I know right away, okay, well, it's not those factors. So let's try another one. When we are multiplying to get a positive number, remember, obviously 2 positives will make a positive, but also 2 negatives. So why don't I try -1? So -1 times -25 will also multiply to give me 25, but that one will add to give me -26. So that can't be right either. I'm not going to move on to 2, 3, or 4. The reason I'm not is because if I divide 25 by 2, 3, or 4, I'm not going to get whole numbers, okay? When you're factoring, you always have to get whole numbers. So if you didn't realize that 25 doesn't divide evenly by 2 and you type that into your calculator, that's fine. Just don't write it in your chart because those can't be the possible factors. Okay, so the next number that I can think of that goes into 25 is 5. Well, 5 times 5 will give me 25. 5 plus 5 gives me positive 10. Okay, we're getting closer, right? We need it to be negative 10 though, so it can't be that one. But what if I try negative 5 times negative 5? Okay, that will still multiply to give me that positive 25, but if I add those together, I will get negative 10. So I know that those have to be my factors. Okay, so notice how those are the same. I'm multiplying the same number together. That means I do have a perfect square trinomial. And the reason for that, you could write this out exactly how you did before. Okay, so we could just write x minus 5 in one bracket and x minus 5 in the other bracket. Okay, but because those are the same, we have another simpler way to write this. We would just write this as x minus 5 squared. Okay, and then if we look back up to our definition here, we can see that that is the answer that we should have got, a plus b squared. Okay, and again, that b value, if we would have just taken the square root of 25, we could have got 5, right? Because it's telling you that that third value is b squared. So in order to get b, we would just take the square root, which is 5. Just another way to look at it. Okay, so this example that we just did is an example of a perfect square trinomial. Perfect square trinomial. And the reason for this is because our first term was a simple x squared, and our last term was a perfect square, right? Our last term ended up being the product of negative 5 times negative 5, which makes it a perfect square. The middle term, if we're simply ignoring the sign, is always going to be 2 times the square root of the last term, right? So that's what I was saying. If we take the square root of 25, so square root of 25 equals 5, and if we multiply 5 by 2, we get not 16, 10. Okay, so that's what this line is saying here. Okay, so to determine the sign of the factors, all right, so we can use this shortcut now. We don't have to go through all of this. We can simply just figure out that it's always going to be x minus that square root of the last term, or half of the b term. Okay, so if the middle term is positive, then the factors are going to be positive. So if the middle term is positive, the factors are positive. If, on the other hand, the middle term is negative, then the factors are also going to be negative. Okay, and if we look up here, our middle term was negative 10, and negative 10 is obviously a negative number, so our factors would also be negative, and we can see that we did have that negative sign in our factors. Okay, if it was plus 10, that would just simply change the sign here, so it would be a plus there as well. Okay, moving on to our second special case. So if we are factoring a difference of squares, so remember that difference of squares means that it's a binomial, so it's going to just be 2 terms. Okay, so it's always going to be 2 terms, so maybe just make a star that it's just 2 terms. Okay, so if it's just those 2 terms, when we factor it, remember this is just the opposite of our expand and simplify. So before, this equation here would have been written backwards. It would have been a plus b times a minus c will equal a squared minus b squared, right? But now we're going the opposite way. So we're given a squared minus b squared, and we need to put it into those brackets. Okay, so when the first term is an x squared, so same as before, and the last term is a perfect square. Okay, so just 2 terms here. So looking at this next example, if we have x squared minus 25, okay, we only have two terms there, but if we want, we could write that as x squared plus 0x minus 25. Once we write this as a trinomial, we know exactly what to do, right? Because we learned how to use our chart. So I have to find two numbers that multiply to give me negative 25. That should be negative. And add to give me 0. Okay, so multiply to give me C and add to give me B. Okay, so one of those numbers is going to have to be negative, right? Because a negative times a positive gives me that negative number. So I know it's not going to be 1 in 25, but what if I try my 5s again? So I know 5 times 5 gives me positive 25. That's not what I want. I need it to be negative. So if I make one of these factors negative, 5 times negative 5 gives me that negative 25, and 5 minus 5 also gives me that sum of 0. So I would know right away that my factors are going to be x plus 5 and x minus 5. But I could have gotten there just by using this formula that you see above, right? I could have just used that formula because it tells me how to do it. So it's telling me that if I factor a squared minus b squared here, all I need to do is I'm going to have two brackets, right? The first term in the first bracket is a. So remember this is a squared and this is b squared. So the first term is a, so x squared. So if I take the square root of that, I just get x. Okay, plus b. Well, b is going to be the square root of 25, which is 5. Okay, and then my second bracket is going to be x again, this time minus that same value of 5. Okay, so I could just use this special formula to factor that instead of going about my chart. Again, if you don't see that right away, or if that's kind of hard for you to understand, absolutely just use this first way we did and use your chart to figure out the two factors. Okay, as you can see, these answers are the same, right? Those are equal. So you can absolutely do it either way. Okay, and again, the reason I got 5 is because I took the square root of 25. Okay, so if we use that special case for our last example here, x squared minus 18, that means I need to take the square root of x squared, which is x, so that's my a value, and the square root of 81, which is 9, and that's going to be my b value. Okay, so once I have my a and b, I just simply plug it into my formula. And again, that formula is a plus b times a minus b. So I fill it in with my values here for a and b, and I get x plus 9 and x minus 9. Okay, so all we have to do is take the square root of both those terms, and that makes it very easy for us. Okay, so in this note, just as a quick summary, it's saying what are the three types of factoring completed above. So in this note, we talked about factoring trinomials. We talked about factoring perfect square trinomials. And lastly, we talked about factoring those difference of squares. And the difference of squares is the one with two terms. Okay, so factoring can be kind of a confusing concept, so make sure if you're confused by any of that, you're asking questions as they come up. Okay, this is the end of this third note.